Hello class, good morning. Class, this is my first revision lecture for you, which I am trying to send you today just to make your good revision for chapter number 1. Kinetic particle theory is the topic, which is under discussion. So today we are going to just revise whatever we have learned and how we can make good understanding and learning for the worksheets which I'm just about to send you in a couple of days. So we see what is kinetic particle theory. Specifically, if you search this topic on the internet, this theory is totally speaking about the movement of particles of a gas phase. But I will explain you this theory to understand the movement and understand the energy levels and the binding forces in all three physical states of matter, that is liquid, solid and gas. And the picture which I have chosen here is just explaining you some very important motion of particles. Yes, I am talking about Brownian motion of particles, and you can see that the particles are moving in different directions irrespective of their previous position. So we begin with the statement. This theory states that all matter is made up of tiny particles, and these particles are in constant motion, the motion which I talked about, which is Brownian motion. And the second postulate is that it describes the states of the matter, in which state they are, means they can be present in solid state or they must be in different movement when they are in liquid state, or the gaseous phase particles must be behaving totally different from the previous two states. And it also explains the differences in properties of solids, liquids and gases and the changes in their states. So we see why it is very important to know about the particles when they are different physical states. We see when the matter is present in the solid state, they seem very orderly arranged, means they have fixed patterns of their arrangement. That's why they are at fixed positions. And when we see the distance between these particles, the distance is the least, means the particles are very tightly packed together. But when the particles or the matter is present in the liquid state, we see they seem a bit relaxed, means they are able to move here and there and they are able to flow over one another. They can slide over one another, means the particles of liquid phase are at some distance and they can move relative to each other. Particles are close enough, but not as the particles they were tightly packed in the solid state. And when I see or study the movement of particles or the position of particles in making the gaseous phase, we see they are totally disordered and they have many more spaces between them. You see the particles are at distance, so this distance is due to very high energy in them and they have complete freedom of motion. They can move anywhere where they want and the particles are far apart. So it is not the first time that a teacher is explaining you about the position of particles. We see why we are understanding all this. You know, there are three main components to kinetic energy. No energy is gained or lost when molecules collide, means when they are in their gaseous phase or liquid phase or solid state, and if they are moving to their mean position, if they are moving over one another, or if they are moving anywhere in the gaseous phase, they do not exchange any energy. Then the molecules in the gas take up a negligible, able to be ignored amount of space in relation to the container they occupy, and the molecules are in constant linear motion. So when we sum up, we know that the three phases of matter are interconvertible. That's why these changes are known as reversible changes. And it's all about giving them energy or taking their energy out. Means when a solid is heated, there are two possibilities. Generally, the solids are melted when they are heated, like in this. When we heat solid particles, they absorb energy and they start behaving as liquid, means they are melting. And when we cool them, the liquid particles again solidifies, which is called as freezing. Another time we see when we provide more energy to liquid particles, they start converting into the gaseous phase, which is called as boiling or evaporation. But in return, when we cool a gas, it becomes a liquid, means the gas condenses. So this is all about the energy of particles, which is making it a different physical state. When I sum up all the properties and when I observe the microscopic properties of these three states, first I cover solids. The solid particles are very slowly moving. They can only vibrate or rotate at their mean position, means they do not leave their places, and they are very strongly bonded. That's why their intermolecular space is the least. But when I see the liquid phase, the liquid particles are fastly moving, or they are a bit faster than the solid state, and their intermolecular bonds are very weaker. That's why they are large intermolecular spacing. And when I study the particles of a gas, I see they are very fastly moving and there are no intermolecular binding forces. That's why their spaces are very large. Now one more thing which can be studied or summarized from this table. It will be very helpful in predicting the properties of these physical states. When I see the particles of a solid are very slowly moving, means they have very low kinetic energy levels. And when I see the very strong molecular bonds, means it has a definite own shape. That's what the solids have. And when I see very small intermolecular spacing, solids are hardly incompressible because there is no space between the particles. Another time when we study the position of the particles, they are faster moving particles because the kinetic energy levels are much greater than the kinetic energies of solid particles, and they are bound by the weak intermolecular bonds because they can take the shape of the container, and their large intermolecular spacing means they are slightly compressible. When you compress the particles of the liquid, the particles can come closer. That's why the liquids are slightly compressible. And when I see the very fastly moving particles of a gas, because of their very high kinetic energy levels, and I see no bonds between them because they take the shape of the container, they can go anywhere. They can go anywhere in the container. And very large intermolecular spacing means they are highly compressible. So this is the end of the lecture with some thought-provoking questions. That why does a solid have a fixed shape? I explained it. Why does a solid have a fixed volume? Why does a liquid not have a fixed shape? And many more questions. You just find the answers of these questions by reading the textbook and by watching this video again and again, and just get command over these fundamentals of these physical states. Okay class, take care. God bless you.